For the more than 500,000 residents of the exclusion zone around the Philippines' Taal volcano, which began erupting on Sunday, the coming days will be a tense wait to see if the eruption will intensify, threatening lives and property, or sputter out. If activity ramps up, Taal is capable of producing all three of the deadliest volcanic hazards: tsunamis, mudflows, and superheated flows of gas and debris. Volcanoes are notoriously unpredictable, but there are seismic signs and others that geologists will be watching for indications of what this one will do. Taal is the second most active volcano in the Philippines Islands, which are situated at the confluence of several tectonic plates. Taal's peak sits at the southern end of the main island of Luzon, about 40 miles south of the nation's capital, Manila. The entire volcanic complex presents something of a geologic Drost effect, a term used to describe recursive pictures within pictures. A lake fills the main crater, which itself is an island in a larger lake that fills the old caldera that formed after catastrophic eruptions about 500,000 and 100,000 years ago. The volcano has erupted 33 times since 1572, most recently in 1977. Since then, it has seen numerous periods of what volcanologists call unrest, seismic rumblings and up and down ground movements indicating that magma and other fluids are shifting below the surface. The quandary for those trying to predict Taal's next moves is that sometimes that unrest leads to eruption, and sometimes it doesn't, says Michael Monga, a volcanologist at the University of California, Berkeley. Taal volcano features a lake within a central crater, itself surrounded by a lake that fills the lake's old caldera. Credit Taro Hama Getty Images. There are, however, particular signs among the symptoms of unrest that volcanologists can look for in order to shed light on what outcomes are more likely. GPS instruments around the volcano can detect whether the ground is expanding, an indicator that magma, gases or fluids are pushing their way toward the surface, which would suggest the eruption will continue and potentially intensify. Advertisement scientists will also be looking for two types of seismic signals, says Tracy Gregg, a volcanologist at the University of Buffalo. If magma is indeed pushing its way toward the surface, and is doing so through a new pathway, it does that by breaking the rock, and that makes a particular kind of earthquake, she explains. If those earthquakes are getting closer to the surface, magma is doing so as well. The second signal is called harmonic tremor, because, as magma moves through the rock at a certain speed, and if the rock pathway is a certain shape, it makes a note, just like air being pushed through your throat when you sing, Gregg says. Detecting harmonic tremor tells us that magma has an established pathway, and it's moving through that established pathway, she adds. For many volcanoes, this situation means an eruption is imminent. The Japan Meteorological Agency's Himawari satellite captured the volcano's eruption over January 12 and 13, 2020. Credit NASA and JMA. During a period of unrest at Taal from 2010 to 2011, Malcolm Johnston, a research geophysicist emeritus at the U.S. Geological Survey, and several of his colleagues serendipitously had instruments in place that could glean more detail about the goings-on under the volcano. They detected fluids or magma moving into a chamber about 1.5 miles below the surface, though that material subsequently retreated, and the volcano settled down. In a 2017 study in the Journal of Volcanology and Geothermal Research that summarized their findings, Johnston and his colleagues suggested the most likely place for the volcano to next erupt was above that chamber, and that seems to be where the current eruption is happening. It's right where we expected it would be, Johnston says. Because of the lava now fountaining from the crater, he suspects that magma pushed its way into that chamber and then toward the surface. One of the main concerns with Taal is the abundant water in its two lakes and the extensive underground hydrothermal system the magma and lava could potentially interact with. When water comes into contact with something hot, it flashes into steam. Water turning into steam is an incredibly energetic change that causes it to expand by a factor of 8, Gregg says. If that change happens in an underground hydrothermal system, the steam can build up until it explodes. That's the scary part, Johnston says. The initial stages of Taal's current eruption were, in fact, such steam-driven, or phreatic, ones, and they sent ash high into the sky. The current eruption also carries a tsunami risk because of the lake surrounding it. If part of the volcano's flank collapses into the lake, it could trigger such a wave. A similar event happened in late 2018 at Anak Krakatau in Indonesia, killing more than 400 people, though it was bigger than what Taal could likely generate. Tsunamis can also be triggered by large, superheated currents of volcanic gas, ash and other debris, called pyroclastic flows, or by mudflows caused as volcanic ash mixes with abundant water. Both of these occurrences can be devastating in their own right, because they can hurtle down slopes much more quickly than the lava people tend to associate with volcanoes. Advertisement authorities in the Philippines have warned that an explosive eruption could happen within hours or days, and they are working to evacuate nearby residents. But volcanologists cannot say for sure if such an event is imminent or if this is just boiling off a little steam, like a pot boiling over on a stove, Greg says. We've just got to keep watching.